Hi guys, welcome to Learning Electronics Repair. I have a Dynacord Powermate 600. I've looked at one of these before, may even be the same one, so little story on this one. This belongs to a guy who I know locally, has a print shop and he does my business cards and such like, and he came in and said, "Can you fix me this urgently, Rich?" Yeah. Also, this guy, by the way, he's a local Elvis impersonator, so he does various gigs, yeah. And he says that he sold this to somebody and they're complaining because these three channels are not working. So this one works, these work, and the stereo channels work, but these three don't work, okay? So he asked me if I could fix it urgently. He says he thinks it's a simple fix, yeah. He's already taken all the knobs off, by the way, and taken the screws out, so he says to me, look, you can just open it up easily. So he's done a fair bit of donkey work on this. Now, he says that he bought this from somebody down in Puerto Rico. That's the resort town in Gran Canaria in the south, not the Caribbean islands. Yeah, we have our own Puerto Rico over here. Very popular resort, very nice, by the way. So he's bought this from somebody in Puerto Rico. Now, I know I've done some work for one of the bars in Puerto Rico on mixers like this, and I wouldn't be surprised if this has come from there, and this is one I fixed before. Yeah, I don't know, just a gut feeling. So, well, he's obviously disconnected this one, and it's here. So we have the mixer panel. I think we can get to this quite easily. Generally with things like this, because you have 6 channels all identical, it's usually not too difficult to figure out why one or more don't work if other ones are working. The most likely things to go wrong with mixers are potentiometers, slider potentiometers, and switches. Okay, now this one doesn't have a lot of switches in it. These will probably get dust in them, especially over here. So my first thought with this is just check these potentiometers, see if they read okay. If they do, then let's put a signal in on a good channel and on a not good channel, okay? And let's see if we can just trace through to see how far the signal is getting before it disappears. All this part must be okay because some channels work, and the same with the power amplifiers. Okay, so we have a bit of a plan there. Let's have a look and see what we can figure out. Another thing the guy brought in was the schematics as well. So I actually have the schematics for this. So that was always a bonus, of course. Looks like there's a few of these bolts that actually hold this down. So he hasn't completely dismantled this. That one doesn't want to move, that one doesn't want to move. There's a strange connector here, which the ribbon cable doesn't seem to fit for some reason. I don't know, we'll have a look, no doubt. Usually the problem with mixer repair is the amount of bolts you have to unfasten to even get inside the thing. They can be a pain in the butt. The second one is that it's often difficult to get the thing in a position where you can power it up and work on it at the same time. Yeah. Not the nicest things to work on, I will say. Okay, so we have the PCB. This is a working channel, 3 bad and then 2 more good. So we see we have either an XLR or a jack input. So these are different. This is for a microphone, this is a line in, so the actual signal level is different. I don't actually know which one he was using. If I have to find out, I'll ask. Then we have the various row of potentiometers for that channel. I'll have to just get the front panel, we can have it to see which one is which without it fitted. And we see here an op amp, another op amp. Now these are dual op amps. I'm pretty sure NE5532. Let's have a quick look. Yeah, low noise dual operational amplifier. We can find a data sheet for that one, but we do have a schematic, which is good. We'll look at it in a minute. Just having a quick look, just to familiarize myself a little bit. So there's a group of 4 transistors on each channel. Okay, then we have 1 op amp here. Yeah, that was probably for this channel and this channel, the dual. Yeah, so there's probably 1/2 is for this one and 1/2 is for this, and then there isn't one there. We have another one here again. We can see, yeah, and I think yeah, we can see one there as well for those 2 channels. So we can say that does both channels. This one 2026. Is that 5/6? Let's have a look. (2026G). That'll be another op amp. This brand's JRC. I see this a lot in mixers. Okay, some more controls. And then we come down to the slider. Again, we have 1 chip for that pair, 1 for this pair, 1 for this pair. And again, we have these as well. So we can see they're clearly in pairs. More of these NE5532. The other chip, LM2901, is a quad comparator apparently. And this one I know is going to be a dual op amp. So yeah, LM2901, quad voltage comparator, and the other one, JRC2026G. Not finding. Let's just take the G off there. We'll have a look for that. Don't say anything obvious. I'll put the JRC in, but you don't normally need to do that. Okay, don't find an obvious data sheet for that one, but I'm pretty sure if we need to, we will. We have the schematic. I'm just having a quick look to see if I see any visible problem on these channels. Okay. Points of weakness, sockets, these could be bad. These ones less likely. Resistor there, but that's just a bit of, oh, I don't know. A little bit suspicious, maybe. But on the other channel, which isn't working, I don't seem to have that problem particularly. Okay, just on this one. There we go. Okay. Okay, the transistors, the pots. So these pots are likely to be where the problem is going to be, I would think. Just going down. Again, these seem to be 1 for each channel. Okay. Same with these electrolytics. They seem to be 3 on each channel. So we have a lot of duplication here, and that is going to help us to repair this. And then the sliders, which is the thing I suspect the most. Because this has these comparators, I'm not totally sure whether the audio is coming through these sliders or whether this is some sort of voltage controlled amplifier circuit. But first of all, let me just have a look to see if these sliders look like they're probably okay. So we'll compare a good channel with a bad channel. Okay. There seem to be 4 pins at this end. This looks like it might be ground actually. Just have a quick look, see if I can find a ground point somewhere. No, maybe not. It's just a thick track that goes up here somewhere. Okay, it just looked somewhat like a ground track. We have 4 pins here. We have 1 there and 1 there, which are probably the mounting points. And then we have 2 more here. So let's have a look and see if we can make any sense of this. I have both pots set to the same position basically, so that's 1.88. That's a bit lower. Let me just move the pots. So those are the actual sliders. Yeah, that's changed the value. That's changed the value. Okay. It's between these 2. They don't seem to connect to anything. Now, it could be that this type of potentiometer effectively has a stereo and a mono version, and these will be mono because these are mono channels, but they'll use the same housing basically, which suggests then that these 2 don't connect to each other, and this is the other end of a slider. Okay. 7K. Other one. About the same. Move the sliders to the other end. About the same. So these could be the two ends of the track. Yeah. And then this be the slider, which is now over this end. Let's see, fifth. Let's see. These about 12. These much lower. So look at the other two bad ones. Again, I'll move the sliders all the way to that end. Okay. I'll do the. In fact, I'll do them all. I have all 6. We can have a look. So from this end to here, I think this is the track. Okay. And they all read about the same. Okay. And they all read about the same. All the other way, and if it stays the same reading, that is a track. So I've moved all the sliders to this end now. So I'll still see 6K roughly. I'm reading across the track basically. So from here to here. Yeah. Here to here. A little bit higher. 7. What was this one again? No, about the same. Okay, and then this is the slider, this one by the looks of it. So here to here. About 360 ohms. 1K. That means different. About 16 ohms. Okay. These are reading quite different. Am I getting a good connection? 16 ohms. That reads higher. That reads higher. This one. 16, 20 ohms. So most of them read about 16 or 20, and that's between the good one and the 3 bad ones. But this one reads different. Okay. On that one. Right, let's push the sliders all the way up. 5, 6, okay. So we measure from here to here again. That's now 7K. Yeah, it's right at the other end of the track. This one. About the same. 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 And then to the other end, so this should be low, about 35 ohms. This one, so these are two good channels, 50 ohms. These are the bad channels. This one is a bit lower actually. This one, and this one is the other bad one. That one appears to have a problem with the potentiometer, but the other two don't, and yet they're all bad apparently. And this one should be a good one. Which also reads like, I'm not getting any sort of conclusive readings, to be honest guys, on these potentiometers at all. I think next we'll have a look at the schematic and then we'll power this up and put some signals in and see what we can see. And hopefully what we can't see, okay? And here it is. So this is the part we're interested in. We see here two audio channels, which are the mono channels. There's effectively 3 pairs of these. We know this anyway. Then we have the same for the stereo channels there as well. Okay, so we're really interested in this area of the circuit. We have then the 2 types of input which feed into this. Now this is a differential amplifier, basically what's called a long-tailed pair. Yeah, long, I hardly managed to pronounce that word, opposite to short. Okay, so long-tailed pair. Okay, that feeds into this op amp, so this is the initial amplification here. That then goes into the various tone networks, high, mid and low, which feed into this stage of amplification. It says it's a TL072. This is the one I couldn't easily identify. Okay, the 2026 or something like that, it said it was. And then we have here the volume control, VR5AA and VR5BA. So these are the sliders. So the audio does pass through the sliders into this stage of amplification. Then we get the various outputs, okay? So master slave, or sorry, master left, master right, out to the FX unit, okay? So the 2 main points of interest, I think, are firstly, do we have a signal here? So the NE5532, pin 1 and pin 7, okay? The first pair are 1 good and 1 bad, so that should tell us a great deal. Certainly that this is working, because any stray voltage, you think, coming in would damage the input stage. Admittedly, there are capacitors here, there are capacitors here, so not particularly likely, but hey, we'll check there. That almost kind of splits the thing in 2 anyway. The second point I'm interested in looking at is here. Okay, so this is on the other NE5532 on the output, again, pins 1 and pin 7. So by measuring that on the first pair of channels, first we'll find out if I can actually reproduce the fault the customer says he has, and secondly, it may well tell us pretty much where the problem is, if there is one. I've balanced this up on a cardboard box basically, so I can work on this while it's connected to the amplifier. I really don't need to connect any speakers, to be quite honest, at the moment. I've plugged in the audio from my computer, left and right channel. I just have some music playing on the computer, but I'm not going to put any speakers on here, don't need it. I'm just interested to see if the signals are present that we saw on the schematic. So all the controls are set the same on each channel. Most of them had like a center click position, which made it easy. So the first thing I want to look at is on this one, pin 1, pin 7. I don't have a ground lead attached to this. I do have a ground lead connected to the mixer, which is here from the other scope probe. I just find that's generally the easy way to do that. Then you don't have the thing flapping around here, either touching your wrist or touching things on the PCB, which is probably worse. Yeah, depending on the voltage, okay. I've just had this running for a few minutes. I've noticed the fans came on. They've switched off now. Okay, if I alter the volume on channel 1, we see this is working on one side. Channel 2, so both channels actually seem to work. Let's have a quick look. I'll just put these towards the middle. I can see the... Well, I could see the signal flashing there. Let's have a look. So, we'll go to pin 1 on the first chip. And we have this audio. And we go to pin 7. We have audio. So, both the channels are the same so far. 1 is working. 7 is working, so they're the same so far. Then the third chip, which is after the slider, is here. 1, 7, and this should be affected by the volume control. So yeah, we can turn it down, we can turn it up. Okay, and the same on pin 1. Turn up, turn down. Okay, so it would appear in actual fact that both of these actually work. I can see the signal LED, certainly this one flashing. This one seems to flicker also. I've just noticed, by the way, I'll just turn these down, that in actual fact both of these are working. It's just that one of the master sliders was down. So those two channels, from what I can see, are actually working. Go on, let's just check these other ones while we're here. Okay, so we're on channels 3 and 4. Power it back up again. Now these two don't seem to work. Okay, let's have a look what we have. Well, that's just going up off the end of the thing, and that one. There's something wrong. Maybe it was these 3 channels then. Maybe I have it wrong. We'll put one of the inputs back onto channel 1, okay, and then we can make some comparisons again. Once again, power up. Both of these are working. This is channel 1, okay. I can see the light flicking. Channel 3 isn't doing anything, okay. Now then, coming in, pin 1, audio. Pin 1. Oh, it goes off the end of the scale. That's not good. Again, pin 1. Audio. Pin 1 is just going... It has a very large DC offset on it, about 4 volts. Pin 7. The same. Okay, that is obviously no input on that one, so that's just 0. What's this doing? The next chip, let's have a look. That's 0, 0. So the problem is actually on these 2 channels, by the looks of it, and straight away near the input we can see there's a DC offset there. Okay, so what we have is the output of both parts of this op amp, and there's 2 inside there, has a negative DC offset. Now that might be because there's some problem with the op amp itself, or it may be because there's some problem on the input circuit on both. But that seems less likely. It seems more likely to me that the problem is the op amp. We can have a look. So I think if there's going to be a problem on the input, if we compare the readings with the thing powered down between a good channel and one of these, we might see some difference, but it seems more likely, I think you might agree, that one component has the problem, which is this one. Okay, we can check, for example, if this has both power rails. Should be plus and minus 15, you would think. If I just put my scope onto 5 volts per division, we should be able to see that without getting the multimeter out, okay? So power up again. Let's have a look. Oh! Minus supplies. Probably to all these chips on this pin. I think we can even go down here. Yeah. So they all have a minus supply, then positive supply. This one does not have. That one does. That one does. That one does not have. Okay. Again, that one does. And then towards the bottom, that one does. That one does not. That one does. How about over here? Yeah. Positive supplies everywhere, but not down this row. Strange. Well, I can see that the supply goes via this link. Okay. Nothing. Yes. Goes through the board there. This is like it's fed from something, the whole row, and there's no connection. But I mean, what's it going to come through? Let me have a look around. I'm going to trace around on this board a bit, see if I can figure out where that actually comes from. Otherwise, I'm going to effectively connect from here to here. Yeah, a bit of wire. But let's just figure out why we have no positive supply rail down these channels. I've had a look around. So this is the ones that have no positive power. Now, we can see for pin 1 here, sorry, pin 8, which is V plus, VCC, goes to pin 8 on this one. Okay, and then that goes to pin 8 on this one, and then on this chip, this LM2901, it's pin 3 as the positive supply. So they're all connected to each other, but they don't connect to the other channels. Okay, so from any of those I was just on, from here to here, nothing. But that one connects to this row. Okay, so it's just this one is isolated from the power supply positive. If you look underneath, we can see, so the chip, this is one of them, this is pin 8, and that is your positive supply rail. Okay, that one. And that goes also, if we look on another channel like here, yeah, but this one it doesn't go. So they should all be connected together. There's no components in between. We just don't have a connection from here to there, basically. I'm going to connect a piece of wire then. I could go from here if I want down to pin 8 on any of them, or I could just connect a pin 8 of one to a pin 8 of this one. I mean, there's very little current flowing in this area, so I'll probably actually do that. Just drop a wire across and let's see if it works. So I have that. There is one other eventuality we should just consider here before we do this, and that's that we have a short on the positive supply on this row to ground, or even to the negative rail, and that's kind of like taking a bit of track out. And I don't see any visible damage. A lot of this is on the other side of the board, and it kind of goes off over that way. You can't clearly see where it's going to, but it's possible that either, I think, A, there's a bad via somewhere, just lost the connection, or B, there was a short on this and it's blown something to lose the power. Yeah, so before I put a piece of wire in, I should just actually check this to be sure. So continuity range again, let's have a look. So this is the positive supply on this block there. Let me just find ground, which appears to be here. Okay, let's have a look. Connect the black lead to ground. So from the working channel, I just read open circuit to ground from the positive and from the negative gives me a reading, but it's climbing up into the ohms and then goes over. Okay, then on the bad channel, okay, nothing, and the same thing climbing up till it goes over. Okay, so there's no short there, and I just go between plus and minus. I don't think really for a minute there is, because if there was, I'd probably have a negative on there rather than zero. Anyway, there's nothing there, so we'll put this piece of wire on and let's see what happens. So from there, and this is the good, or one of the good pairs of channels. Okay, a little bit of flux. Right. Have a connection on there. Okay, there we have it. So we'll just go to the other side. Yeah. So this is pin 8. This is where we had a connection on this channel. Was okay. We'll now go to the other channel. Yeah, we have a connection now. Okay. Okay, so they're all connected together now. Okay. And that applies. I was down here where you couldn't see where I was. That one and that one. Okay, so we have the power there. I suspect this will now work. Let's just give it a go. I don't think I even need to have the oscilloscope attached now on this. We should be able to tell from the LEDs what's happening. So I've turned all the sliders down, switch on, give the output a bit. This is channel 3, 4. And there's nothing there. What voltage do I have on that missing power rail now? Let's have a look. Okay, so this was the missing power rail. It's now plus 13. Oh! And something's burning down here. Okay, so we have smoke. Interesting. Well, that suggests, I'm just looking now, that I have the negative supply. Okay. And that's connecting to the negative supply down here. Okay. It's not connecting to ground. Okay. Feels like a resistance, which is fairly low actually, to ground. Okay. And then we have the positive supply, which is here. And that goes to the positive supply on these ones. Okay. And that also means a fairly low resistance to ground. Okay, now let me take that wire link back off, because I strapped from this one to this one. Okay, and it looks like this row is drawing too much current for some reason. There's something wrong on this side. So the resistor that powers or supplies the power to this, and there must be some low ohm resistor in here, which I didn't see, is now burning up. Let's have a look. So I'll just unsolder my bit of wire. It's in the right place. It's fine, by the way. Okay. Let's check that resistance now. So positive supply now reads effectively open to ground. Negative supply, put the black lid on, reads basically open to ground on this one. That reads open to ground. And that reads a low resistance. So that's why that started smoking, because I put the power back on here. And somewhere in here, one of these chips or something else that's connected to the positive supply rail is faulty and drawing too much power. Let's have a look and let's see if we can see what's actually burnt as well. Okay, so what actually burnt up was this resistor R44A, okay? And if we look on the bad channel, R44B is already burnt up. So this must be where the supply comes in. This capacitor is completely black, and that is the problem. Yeah. How many of you saw that one earlier? So that's the fault. Yeah. That one's okay. That one's okay. I'm surprised I didn't see that before. Maybe I just assumed it was a black component. So we know the resistor, because there's one here, R44C, is 20 ohms, 20, and no more zeros. That must be a 20 ohm resistor, I would say. Let's have a look. Reads 10 ohms, but that looks red to me. Oh, I see. 10 and no more zeros, and that's a tolerance 2% or something like that. There's another one here, look, same value. Yeah, the one I've just fried is now basically reading open, okay. And then obviously this one is reading open, which is why we had no positive supply, okay. All becoming clear now, and that's the fault. So that capacitor will be the same as one of these. Looks like some sort of tantalum. This shouldn't be too difficult then to repair this now. I can see another one of those capacitors here. It says 302. I'm not sure that is a tantalum at all. That's like 3000 picofarads possibly. Yeah, which would be 3 nanofarads. Let's have a look. So we have C31, C32, 100 nanofarads. So they're just normal, like ceramic type capacitors, encapsulated, I would say. So 100 nanofarads. We'll replace that capacitor. We will replace those two resistors. We should be able to find those as well, actually. So, good example being R44B. I'm not sure if this is actually a searchable PDF or not. No, doesn't seem to be. I can't easily see where it is. Well, I can just check, and I'm sure this will be the case. That one end of this goes to ground. That end, and the other end of this will go to this power pin, okay, which is the other end of that resistor. Yeah, okay, so change that, change the other resistor, see what happens. Those are the dead components, so the capacitor didn't come out in one piece. That caused a problem. This is the 10 ohm resistor, and the other one, you can see now they are 10 ohms. There's a problem with the color balance on my overhead camera. Brown comes out looking as red quite often, so that does make sense. The 10 ohms also 10 ohms as a standard value, if you like, and 20 ohms is not quite so standard value. So 10 ohm resistors go in. They also measure 10 ohms, the good one at least. I'm sure they're on the schematic somewhere. They just wasn't that obvious where they are, but I'm happy enough to put 10 in. So I'll put 2 resistors in here. I'll replace this capacitor. We can just double check. So if we now go from the positive rail on the chips to ground, there's nothing there now. This is where the resistor was. This is one side, this is the other side. Okay, so the low resistance is gone. These will no longer be connected together because the resistors are missing. Okay, we can go on to the good channel, so positive, ground, say good channel. This is the one with the resistor intact. So there's no short there anymore. A couple of things didn't help here really. One is that I didn't spot the burnt component, unfortunately. Or I should say burnt components. Yes, that's the first problem. The second one, I don't think I did myself any favours when I was on the right track. Is there a short on this rail causing the thing to lose a connection to the plus 15 volt supply? The fact is, well, there was a low resistance there. The problem I had there, I think, is when I was trying to read to ground before on the back of the board. I don't think the ground I had was a good ground point. We can just check. So I actually thought that this is ground. Oh, it is a ground point, so I'm surprised I didn't see it. Oh, you know, I was in continuity mode and I was looking for shorts, and the fact it's like 40 something ohms, that's over the range for my continuity, so I didn't see it. The other interesting thing, when I was measuring to see if they were all connected together, these plus 15s, I didn't really see the 10 ohms, which I should have done on the ones that were connected together. Interesting. Okay, so anyway, let's get these resistors fitted in this capacitor. Let's see if it now works. Okay, so 100 nanofarad capacitor, resistor 10 ohms, resistor 10 ohms. What do you think it will do now? Well, again, we'll just watch the lights, see if the signal lights flash. Okay, what's it doing? Lights flashing, at least on that one. Nothing on the output though. Okay, turn the output up a little bit. Just check again. Seems to power up okay. Oh yes, it's working. Yeah, 3 seems to be working. Not 4. I might have a bad connection there on the audio coming in. I'll just check that. Sometimes this leads a little bit iffy. Okay, let's go again. 3, 4, turns 1 and 2 down. Okay. Yeah, we definitely have output now. Okay. On channel 3, but not on 4. Interesting. Just disconnect this lead, plug this into here. Okay. So we still appear to have a problem on channel 4, but 3 is now working. I'll just check the plus and minus 15, but I'm confident enough they are okay now. Okay, let's have a look. So minus 15. Yeah. Plus 15. So the supply rails are okay. Let's have a look to see why channel 4 still isn't working. Oh, hold on. I bet the gain's turned all the way down. Possibly. That's clipping now. Just stop it clipping. No. Is there some stupid problem with my jack connector? They're not the best things in the world. Oh yeah, look, it's going now, okay. Both going. So that was just some problem there. Okay, so they're actually working now. I've just attached my speakers. We'll have a quick go with this. Yeah. Yeah, that's fine. Okay guys, so I think we can say we fixed that. That is a problem the customer said he had with this. So yeah, that is done. That was an interesting repair. As I said, I think a couple of times I made that a bit difficult for myself there, but hey, if I make mistakes, I fix it in the end. And hopefully you guys will learn that we all make some mistakes, but it's the result that matters. Okay, hope you enjoyed that. Hope you enjoyed a little bit of Northern Soul there. And I look forward to seeing you all soon on another Word Electronics repair video. Ciao for now, guys.